So in the series of videos, as you know, we are talking about various standard functions. This is the last part where I'm going to be talking about two more special functions. So let's get started. The first one is exponential functions. So again, look at the name. We are talking about exponents. So it's from R to R, fx equals to a to the power x, where x is any real value, which is actually the input. Now concentrate on this a. There are certain restrictions. It is actually greater than 0 and it's not 1. Think about the interval. So either it's in 0, 1 or 1, infinity. The domain is R because we can have any real input. The range is very, very important because whatever be the input, you understand that A is between 0 to 1 or 1 to infinity. So the range will be from 0 to infinity. What is the next thing? We talk about graphs. Now here you have to be very careful because you understand that since it's between 0 to infinity, there are two portions which are very important. Either it's from 0 to 1 or 1 to infinity. So we can have two different cases and they will behave differently. You take any value which is less than 1, suppose half. If you plot the numbers here, this is how the graph will look like. Because in this portion, as the value increases, the actual output will decrease. So be very careful, and that is why we are making two cases. As you can see, if x is 2, this is 1 by 4. If x is 3, this is 1 by 8, and it's decreasing. Similarly, take any value greater than 1, it will actually keep on increasing. So this is how the value will look like, and the graph will be actually represented as this. So since we made two cases, let's combine them. This will be the graph of the exponential function. So this part is corresponding to the values where a will belong to the range of 1 to infinity. This will be the type when you have a in 0 to 1. Now, apart from this general form, we have a very special form, which is e to the power x. This is a natural form of an exponential function. It's a special case where a is e. And as you know that the value of e is between 2 to 3, so we are considering the case where a is greater than 1. So think about the graph here. This is how it's going to look like. Fair enough? The domain is R and the range is the same. So this is a special type. So this is all about exponential functions. I hope you understand the definition as well as the graph, domain, range, etc. Building on this concept, I'm going to talk to you about logarithm functions. So if you remember the original thing about logarithm, you know that this is of the form log x to the base a, where a is a positive constant. The first thing that comes to your mind is this was the exponential form. I can write down it in the logarithmic form as if y equals to a to the power x, then exponent x can be written as log y to the base a. Now, if I take this logarithmic form, you will see that this will be the corresponding exponential form because x will be a to the power y. If you actually see, they're just inverse functions. So we are doing the same thing, but from the opposite direction. So what we are going to do is now we that know about, logarithmic functions, when it comes to the graph, we are going to explore a very interesting thing. So this was the graph of the original exponential function. For logarithmic function, what happens is this x and y are getting interchanged. So if you look at the axis and how the graph will look like, the logarithmic function will have a graph of this form. If you look at this red branch, it's actually corresponding to the values which are lying between 1 to infinity, and this will correspond to the values which are lying between 0 to 1. So this is all about exponential and logarithmic functions. On many occasions throughout calculus, you are going to need all these various standard functions. So I hope you understand them properly. Repeat them, try and understand the significance, the definition, graphs, etc. So that's it from these series of videos. In the next series, we are going to talk about some special concepts about functions. So stay tuned.